Hello there, my name is Preet Patel and my project partner Mayur Kalal. We both have just completed our civil engineering from Pandit Deendayal Energy University. During our 8th semester, we had been working on the project named GIS-based Solar PV Farm Site Selection using Analytically hierarchy process approach for Sabarkantha district, Gujarat, India. We have done this project under the guidance of Dr Naimish Bhatt and Dr Shobhit Chaturvedi. Sabarkantha district is located in the state of Gujarat, India. It is a region of significant geographical and cultural importance. It is situated in the eastern part of Gujarat and shares the border with Rajasthan and Madhya Pradesh. The district spans an area of approximately 8,000 square kilometers. These are some of the famous places in the Sabarkantha district. First is Polo Forest, second is Dolachula's Palace, and third is Idar Fort. A research game. This research aims to identify optimal locations in the different talukas of Sabarkantha by using the multi-criteria decision analysis. The project's main goals are to increase the quantity of solar energy production, mitigate the chemical emission, and enhance the land use practices. However, no study comparable to this has been carried out in Sabarkantha district. Such investigation should be conducted for the benefits of neighborhood. These are the research objectives: to identify potential location in the Sabarkantha district that would be ideal for the installation of solar panels. Second, develop thematic maps for the selected criteria for the selected region. To apply GIS and MCDM technique to select a suitable site for the solar farm installation. Third, applying an analytical hierarchy procedure to a specific set of relative criteria weights. Fifth, provide a source of power that is both suitable and kind to the surrounding ecosystem. Research scope. The focus of this study is to conduct a comprehensive analysis of solar sites within the 9 talukas of Sabarkantha district, Gujarat, India. Research methodology. This is the methodology chart. First of all, we had find the different criteria from the literature review that are essential for consideration while selecting the optimal location for solar farm. The criteria are land cover, wind speed, distance to urban areas, distance to water bodies, distance to major roads, distance to substations, solar irradiation, land surface temperature, slope, and elevation. After that, we had set them into the same projection. Then we had done conversion and reclassification of raster layers. Then we went for the expert's view and conducted the survey from different people having the similar domain to solar. After survey, we find the weights of different criteria by using the AHP, and lastly, we applied the MCDM, that is TOPSIS method, to find the optimal sites and rank them. Then we had created the thematic maps of different criteria. Here, the left side map is the normalized ground elevation map, and right side is the reclassified map for the ground elevation. Here, the right side map is the reclassified maps, which is categorized into 5 different categories. Red color shows the not suitable region, and blue color shows the most suitable region. We had done this for the different criteria like wind speed, solar radiation, land surface temperature, proximity to substations, proximity to water bodies, proximity to roads, ground slope, proximity to urban areas, land cover map. Here, the left side normalized map shows the different categories like water, trees, flooded region, crops, built up bare and rangeland. This is the criteria layers and their sources. Now, we had performed the analytically hierarchy process for the 10 criteria by comparing with each criteria and find the weights of each criteria. These weights are based on the survey that we had conducted from different people having the background related to the solar. Here, these are the weights and their corresponding ranks. Here we got the first rank and highest weights for the proximity to substation, and we got least weight for the elevation. We had also done the weight check by finding the consistency index and consistency ratio. Here we got consistency ratio less than 0.1, then therefore we can say that the weights are accepted. Here the lambda max is the average of A4 matrix and n is the number of factors. Now the further presentation is carried out by my friend Mayur.
Hello, I am Mayur Kalal, and so by weight criteria and analytical hierarchy process, we have find the final suitability zoning of 10 talukas of Sabarkantha district, and this is our first taluka Vijayanagar, in which we have identified the best 10 suitable sites for solar farm site installation. So this is the map of Vijayanagar Taluka, in which we have identified the suitability criteria, in which red color shows not suitable and blue color shows most suitable sites in Vijayanagar Taluka. We had also plotted a graph between SI plus and SI minus, which, which means SI plus means ideally best suitable sites and SI minus means ideally worst suitable sites. By using TOPSIS calculation, we have plotted a graph of Vijayanagar Taluka. Similarly, we had also find the Taluka map of Prantij Taluka, in which we have identified suitability criteria, which is red color not suitable and more suitable is blue color. It identified the 10 best sites in Prantij Taluka also. Similarly, we had identified the graph between SI plus and SI minus of Prantij Taluka. In Mombasa Taluka, similarly, we had identified the map in QGIS and located 10 best sites in Mombasa Taluka of best solar farm installation and given the ranking accordingly, in which, as you can see, site number 1 is the rank 1 with the highest weightage. It is most suitable site and most in Mombasa Taluka. We have identified the graph of SI plus versus SI minus in Mombasa Taluka. Similarly, for Megris Taluka, its map and suitability criteria and its graph of SI plus versus SI minus. Similarly, for Gate Brahma Taluka, its map and suitability criteria and graph of SI plus versus SI minus. We have done this graph by using TOPSIS calculation. TOPSIS is nothing but technique for order performance by similarity to ideal solution. Similarly, we have identified the map for either taluka, in which we have noted the suitability criteria, which shows red color not suitable and blue color most suitable, and identified 10 best suitable sites in either taluka also. Similarly, we have identified graph of SI plus versus SI minus, which is ideally best versus ideally worst site in Bodasa taluka. For Biloda taluka, this is the map and suitability criteria. By using TOPSIS calculation, we have plotted graph of SI plus versus SI minus in Biloda Taluka also. Similarly, for Himadnagar Taluka, its map and suitability criteria and its graph of SI plus versus SI minus. Similarly, for Bayat Taluka, its graph and its suitability criteria. And then finally, we have concluded that in Sabarkantha, the most 9 suitable sites of which are the best for installation of solar farm, and we have identified the same for Sabarkantha district and identified the most suitability criteria, in which blue color shows most suitable and red color shows was suitable. As you can see that site 8 is the highest weightage with rank 1 of Sabarkantha district, which is site 8 is in Bayat Taluka. Similarly, we have drawn a graph of SI plus versus SI minus of Sabarkantha district. And finally, we concluded that this research process a comprehensive model for site selection of solar power plants in the semi-arid Sabarkantha region province. It considered climatic, environmental, and orographic factors, employing the TOPSIS method to identify the 10 best suitable locations in each taluka, and also find that it would be more helpful for sustainable solar energy project, and so that the consumption of renewable energy will increase and which will be helpful in future. And that's all. I hope you liked our presentation and our major project of solar farm site selection in Sabarkantha district. Thank you.